Okay, Assalamualaikum and good day everyone. So today we are going to continue with lecture 2 of 4 for data description, which is we are going to focus on the 6.3 subtopic and 6.4 subtopic, measures of central tendency and measure of dispersion. So there will be 2 subtopic we are going to discuss. But for now, we are going to focus on the ungrouped data. Okay, let's see the learning outcome. So at the end of the lesson, students should be able to find and interpret both of these works. You need to find and then you need to interpret the mean, median, and mode for ungrouped data. And then explain the symmetriness and skewness of a data. And lastly, to find and also interpret the range, variance, and standard deviation for ungrouped data. So our focus now is for ungrouped data only. Okay. Measure of central tendency. So a measure of central tendency is a measure that tells us where the middle of a bunch of data lies. The middle of a bunch of data lies. The three most common measures of central tendency are the mean, median, and mode. Okay, so we are going to focus on mean, median, and mode. There are several measures of central tendency, but we are going to focus on these three only. Okay. Measure of central tendency for ungrouped data, what it means or represented by x bar is the mean, also called the arithmetic mean of a set of value, is a number obtained by adding the values and dividing the total with the numbers of values. Okay, suppose that the data set consists of n observed values. So we have n observed value. Let's say 10 observed values or 11 observed value. So denoted by x1, x2, x3 up to the xn. Then the mean is obtained by x bar and is defined as x bar equal to x1 plus x2 plus x3 plus and so on up to xn, and divide with the number of observed value. Okay. So what we need to do is to find the average. So the median x curve. So the median of a data set is the middle value when the original data values are arranged in ascending or descending numerical order. Okay. So in general, with n observed value arranged in order of size, the median is calculated as follows. So if n is an odd number, okay, so the observed value, we have observed odd number of observed value, then the median is n plus 1 over 2 observation, okay, ordered value. The position is n plus 1 over 2. But if n is even, then the median is the average between n over 2 observation and n over 2 plus 1 observation. Okay, so you have to remember lah. What we need to do is to determine whether n is odd or even number. And lastly, for mode. Mode x cap. The mode of a data set is the value that occurs most frequently. The mode may not exist, or even if it does exist, it may not be unique. Okay, it can be unique, but it may not be unique also. Okay, so let's see this example 1. So find the mean, median, and mode of the following numbers. So we need to find these three for the following numbers. So for the data A, we have how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11. To find mean, we just have to find the total of the data and then divide by 11. So the total of the data, we can just use a calculator and find the average, which is equal to 14. Okay, so this is we do as manually. Okay, arrange the given data in the ascending order. This is for median. We need to arrange the data in ascending order first. So after you arrange the data in the ascending order, because the observed value is equal to 11, which is odd number, so the formula for the median is n plus 1 over 2 observation. So what is our n? N is equal to 11. So 11 plus 1 over 2 is equal to 12 over 2, which is equal to 6 observation. So which one is the 6 observation after we arrange the data? So we have 1, 2, 3, 4, 5, 6. So this is our median. So the median is equal to 13. Okay, lastly for the mode. So we need to look at the data that has the most frequent. So we can see that 13 repeated by 3 times. Other than that, we don't have any repetition. So 13 occurs 3 times. So the mode is equal to 13. Okay, so that's for the first example. The second set of data, we have 15, 16, 18, 20, 22, and 24. Okay, now to find the median first, we just have to total up all the data and divide with how many data we have? 1, 2, 3, 4, 5, 6. So total up everything and divide by 6. Okay, so we have the mean equal to 19.2. And then for the median, what we need to do is to arrange. But now our data is already in ascending order. And the n is 6, which is even number. So what we need to do is to find the average between the middle data, which is the n over 2 and n over 2 plus 1. So n over 2 is 3, n over 2 plus 1 is 4. So find the average between the third and the fourth observation, which is the third and the fourth is 18 and 20. So the median is equal to 18 plus 20 divided by 2, which is equal to 19. And lastly, the mode. Do we have any repetition of the data? No. So we don't have mode. So each data occurs once. So mode, there is no mode. Okay. Therefore, the set has no mode. Okay. Lastly, example C. Find the mean, median, and mode for the following numbers. Okay. Okay. So now, how many data we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Also 11. So total up everything and divide by 11, we get the mean equal to 3.82. And then for the median, the data already in the ascending order. So because we have n equal to 11, so we have is an odd number. So we just have to find the n plus 1 over 2 observation. So n equal to 11 plus 1 equal to 12 divided by 2 is equal to 6. So 6 observation, which is equal to 3. So the median is 1, 2, 3, 4, 5, 6. So the median is equal to 3. So 3 is the 6th observation. And for the mode, because we have repetition of 1, 2 times, 2, 2 times, 3, 2 times. So we have more than one mode. Okay. So 1, 2, and 3 occurs twice. So the modes are 1, 2, and 3. So we call this as multimodal. Okay. Because we have multiple of modes. Okay. So let's see some example. The given values are the service times in seconds of McDonald's drive-through customers. So find the mean, median, mode, and interpret the values. Okay. So interpret, this is what we need to do now. We know how to find mean, median, and mode already. But for the interpretation, so what we need to do is just to write down back the answer in the situation. So we need to relate what we understand about mean, mode, and median with the situation here, which is service time in second of McDonald's drive-through customers. Okay, so we need just to interpret, write down back in your sentence lah, related to the situation. Okay, so to find the mean, find the average, we get the answer equal to 69.6. Okay, so what we can say about the interpretation? So average, mean means average, right? So we can say that the average, on average, secara purata, the customer spend 69.6 seconds for the service. Okay, because the service time is, this is the value of, this is data about the service time. So the customer spends 69.6 seconds for the service. Okay. Okay, now to find the median, first of all, we need to rearrange the data in ascending order. Okay, so from here we know the 35 will be the smallest data, and so on. Okay, so after we arrange, what we need to do is to observe how many data we have. So from the data, we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 data. So an odd number lah. Okay, so n is equal to 11 is an odd number. Okay, so we have to use the formula of n plus 1 over 2 observation. So n plus 1 over 2 observation is equal to 12 over 2, which is the 6th observation. So which one is the 6th observation? Yes, we have 65 as the 6th observation. 1, 2, 3, 4, 5, and 6. So 65 is the median. And for the next one, to find the modes. Okay, before that, how do we interpret this answer? So medians means that it will be in the middle. So 50% before that value and 50% more than value. So we can also determine or do the conclusion that 50% of the customers spend less than 65 seconds of the service. So this is 65 seconds. So half of the customers spend less than 65 seconds for the service. Okay? Or you can also say that half of the customers spend more than 65 seconds for the service. But usually we use less lah. And then lastly, for the mode, we need to find which one is the most frequent service time. So we can see that 65 is repeated by 3 times, the most frequent lah. So we can also state that the mode is 65. So the interpretation is that most the customer spends 65 seconds the most for the service, or most of the customers spend 65 seconds for the service. Okay? Okay, now let's learn about symmetry and skewness. So the shape of the data is often described by its symmetry or non-symmetry, also called as skewness. The sum distribution of data such as the bell curve are symmetric. This means that the right and the left of the perfect mirror image of one another. So bell curve, if you remember how the bell look like, it will be like this, right? This is our bell. Okay, so it will be the symmetriness about this bell shape lah. Okay, set of data that are not symmetric are said to be asymmetric. The measure of how asymmetric a distribution can be called as skewness. As we will see, data can be skewed either to the right or to the left. So skewed means that if it's skewed to the right, so the tail will be on the right because the data is mostly on the right side. So the mean, median, and mode are all measures of the center of a set of data. So the skewness of data can be determined by how these quantities are related to one another. Okay, skewed to the right. The data that are skewed to the right have a long tail that extend to the right. Okay. An alternate way of talking about a data set skewed to the right is to say that it is positively skewed. So right related to positive. Okay, in this situation, the mean and the median are both greater than mode. Both greater than mode. So mode will be the smallest value. Okay. In the case of 123 of staff cars were obtained at the Authors College and their ages in years, the estimated mean, mode, and median are 5.93, 4.88, and 5.4 respectively. Using these values, a graph can be plotted as below. So we can say that the mode is the smallest value, so it should be on the left side. And then after that, we have 5.93, which is the mean. And then lastly is the median 5.4 is the median in the middle. And then the mean will be 5.93 will be on the right side. So we can say that the mode is on the left side of mean and median. So in this case, a distribution is said to be positively skewed or skewed to the right. The tail will be longer on the right side. Okay. skewed to the left. Data that are skewed to the left have a long tail that extend to the left. An alternate way of talking about a data set skewed to the left is to say that is negatively skewed. In this situation, mean and median are both less than mode. Okay, so it will be opposite of the skewed to the right lah. So we can see that mode will be the bigger value on the right side. So the tail will be on the left side. Okay. So symmetric distribution. A symmetric distribution is one where the left and the right hand side of the distribution are roughly equally balanced around the mean. So mean will be in the middle lah. For the symmetric distribution, the mean is approximately equal to the median. Okay, also approximately equal to the mode. Okay, this is a so-called normal distribution. So we will learn about normal distribution in another chapter. Okay, let's see the example 3. Is the following data set symmetric, skewed to the right or skewed to the left? Justify your answer. So to find whether it is symmetric, skewed to the right or skewed to the left, what we need to do is to find all the three measure of central tendency, which is the mean, median, and mode. So to find the mean, find the average lah. How many data we have? 1, 2, 3, 4, 5, 6, 7. So 14 data. So total out everything and divide by 14. So we have the answer of mean is 41.1. And then how about the median? So median, we need to rearrange the data first. So now we have the arranged data. And now, because we have 14 data, so 14 is an even number. So we need to find the average between 14 over 2 and 14 over 2 plus 1, which is equal to 7 and 8 observation. Okay, so which one is the 7 observation? So we have here is equal to the 41 and the 8th observation is 42. So the average between these two value is 41.5. So the median is 41.5. How about the mode? Do we have any mode? Because we don't have any mode, we just have to compare between mean and median. So mean is less than median means that yes, it is a skewed to the right data, skewed to the left data. Okay. 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 So now let's continue. Okay, now so we now discuss about the measure of dispersion. Okay, so this is the second of the measurement for the statistics. So one measure of central tendency are used to estimate normal values of the data set. Measure of dispersion are important for describing the spread of the data or its variation around the central value. Okay, so two distinct samples may have the same mean or median, but completely different level of variability or vice versa. A proper description of a set of data should include both of these characteristics. So we cannot just focus on the central tendency. There are various methods that can be used to measure the dispersion of data set. So the first one is to find the range. So how to find the range? Range defined as the difference between the largest and the smallest sample values. So one of the simplest measure of variability to calculate, okay, depends only on extreme values and provide no information about how the remaining data is distributed, because it will take the largest and the smallest only. So in the middle value, we don't know what happened. And the second one is variance and standard deviation. So these two is really important. Now we have the formula separate from the group and ungrouped data. So for variance and standard deviation, they both measure the spread of the distribution about the mean. Okay. So an advantage of the standard deviation as compared to variance is that it expresses dispersion in the same unit as the original value in the sample or population. So standard deviation give the original unit, okay, because the variance will be the square units. Okay, for example, the standard deviation of a series of measurement of temperature is measured in degrees. The variance of the same set of value is measured in degrees square. Okay, it will be the square root of the standard deviation. Okay. Standard deviation is the measure of spread most commonly used in statistical practice when the mean is used to calculate central tendency. Thus, it measures spread around the mean. Because of its closely with the mean, standard deviation can be greatly affected if the mean give a poor measure of central tendency. Standard deviation is also useful when comparing the spread of two separate data sets that have approximately the same mean. Okay, the data set with the smallest standard deviation has narrower spread. Okay, smaller standard deviation has narrower spread of measurement around the mean, therefore usually has comparatively fewer high or low value. So means that all the data mostly around the same value lah. Variance and standard deviation. So these are the formulas. So the variance of an ungrouped data, which is denoted by S squared, is denoted by, so we have the X minus with the X bar, which is the mean, and then we square the value, the difference between the data and the mean. Okay, and then we total up everything, every value, the difference between every value with the mean, and divide by n minus 1. Okay, so another formula, we also can find what is the summation of x squared. So all the data we square and then we total up, and then minus with the square root of the square of summation of x, and then divide by n, and then everything will be divided by n minus 1. Okay, so this n minus 1 is the same as the top one lah. Okay, so we have two formula we can use lah. So standard deviation, we just have to square root of the variance. So square root either one of these two lah. So either the first one or the second one. So which one we should use? So it depends on the data given in the question. So if it's given the difference between x and the mains, then we can use the first formula. But if we have the raw data, so directly we use the second formula. Why? Later I will show you how to use the calculator. It will be easier because we can find out directly what is the square root of x squared and the summation of x squared and summation of x directly from the calculator. Okay, example 4. Consider the following sample. First of all, they ask you to calculate the mean, and then calculate the variance and standard deviation. So the mean, how to find the mean? We use the formula summation of x over n. So we have 4 data, total up everything. We have 12 over 4, which is equal to 3. So this is our mean. And then calculate the variance and standard deviation. Okay, so we can use either one formula. But because this one is really small data, we can use the first formula lah. Because we know already what is the mean, right? Because we know already what is the mean, we can use the first formula. So the difference between the x bar and each of the data. So we have the data at 1, 3, 4, 4. So the difference will be xy minus 3, xi minus 3. So the first data is 1 minus 3, which is equal to negative 2. So the square root will be 4. And then for the second data, 3 minus 3, which is equal to 0. The third data is 4 minus 3, which is equal to 1. Fourth data also 4 minus 3, which is equal to 1. And then square of all the values, we get negative 2 square equal to 4, 0, 1, 1. So the total will be 4 plus 0 plus 1 plus 1, which is equal to 6. So the answer will be 6 over 4 minus 1, which is 3. So 6 divided by 3 is equal to 2. So this is the variance, which is equal to 2. How about the standard deviation? The answer will be square root of 2, which is equal to, you can put the answer as square root of 2 or just put in points, which is equal to 1.414. So this is the answer for part B. Now continue with the next example. Example 5. Find the variance and standard deviation of the following data. Now we don't have to find mean. Means for finding the variance and standard deviation, we can directly use the second formula. What is the second formula? Summation of x squared and then summation of x. Okay, so because I can show you how to use calculator right now, what you need to do is to put the data, everything inside the calculator. Okay, later I will show you. I will show you in tutorial. Discussion in tutorial. Okay, first of all, we can put all the data inside the calculator. We should use the mode statistic. Okay, statistic, and put the option. We choose put the data inside the calculator. And later we will have the all the information given. Okay, but now for you to use it manually, we just have to calculate each of the data lah. So for summation of x, we just have to total up everything, right? But for x square, we need to find the square of the data. Okay, now we know the data we have 1, 2, 3, 4, 5, 6, 7, 8. So number data is 8. Now to find the summation of x square and summation of x. So we have the table here and square of each of the data. Okay, square each of the data. We have summation for x will be 72, and then square each of the data, we get 750. Okay, for this value, you can skip finding each of the x square because we can use calculator to find summation of x and summation of x square. Directly use the calculator. Okay, later I will show you in separate video lah. Okay, so after you find out what is the summation of x and summation of x square, you just have to put into the formula. Okay, so the marks will be given after that is when you substitute all the correct formula into the correct values into the correct formulas. So we have 1 over 8 minus 1 multiplied by square root summation of x square equal to 750 minus with 72 square summation of x, and then square kan dia divide by n, which is equal to 8. Okay, so just put in your calculator, directly we get the answer equal to 14.571. So this is for variance. For standard deviation, it will be square root of variance, which is square root of 14.571. Or if you have the answer in the calculator, you just have to put square root of answer. Okay, square root of answer. Don't just put this value. We need to put square root of answer from the calculator. Okay, so we get the answer 3.817. So always give your answer in 3 decimal places. Okay, so this is the answer for the variance and standard deviation. Okay, lastly, coefficient of variation. So after we learn about the measure of central tendency, measure of dispersion, so we need to use this coefficient of variation. So it should be CV, capital V, not small v. So the coefficient of variation is the standard deviation divided by the mean of the same data set and expressed as a percentage. So CV equal to standard deviation divided by mean multiplied by 100%. So we already find out what is the standard deviation, find the mean. So just divide the standard deviation and the mean, multiply by 100%. So a larger coefficient of variation means that the data is more dispersed. Okay, more dispersed and less consistent. Okay, so if it's smaller, that will be less dispersed and more consistent. So it will be vice versa lah. It is useful measure for comparing the degree of variability. Okay, degree of variation, stability or consistency from the one data set to another. Okay, note that if the expected return in the denominator of the calculation is negative or 0, the ratio will not make sense. So it means that the mean, the standard deviation cannot be negative or 0 lah. So let's see this example. We are comparing the data. So calculate the coefficient of variation for A and B, and then which set of the data is less dispersed and more consistent. So if we look at the previous slide, it is said that if it has a larger coefficient of variation, then it will be more dispersed. So now to find the data that less dispersed and more consistent, we need to have the smaller coefficient of variation. So now, what is the CV, coefficient of variation for set A and set B? So we just have to use the formula lah, CV. So the formula for the set 1, we have standard deviation 2.3. 2.3 divided by 14 and then multiply by 100%. We have the answer 16.43%. And for set B, we have a CV of variance 0.6 divided by, variance 0.6. So the standard deviation is square root of 0.6 divided by the mean, which is equal to 7. Multiply by 100%, we get 11.07%. So which one will be less dispersed? Less dispersed should be less value of CV. So it should be B lah. Data B is less dispersed and more consistent because this one is smaller. Okay, smaller. Okay, so the answer is data B. Okay, so that's all for ungrouped data. For the next one, we are going to focus for the it's still ungrouped. Will be ungrouped data, but in another way, method of data representation. Okay, so you can try to do tutorial question. Okay, thank you, class.